So in our last video on Newton's third law of motion, we said that we're going to do a summary, just in case if you just want to remember some other stuff. So here's the summary. So we're going to start with Newton's first law. An object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an unbalanced force. This means that an object at rest will stay at rest. It was pretty understandable because if you put maybe some item down, it will always remain there unless you move it or do something else with it. The object in motion will stay in motion was pretty odd because whenever we move an object, eventually it will stop. But we know that the unbalanced force was air resistance and friction. And also inertia is the resistance of any physical object to any state of its change. So it means that the inertia was what we have to overcome when pedaling a bicycle. Now law 2 is the more inertia an object has, the more force is required to accelerate it. And that could be expressed as an equation that is F equals ma, or force equals mass times acceleration. We knew that force is measured in something called newtons. 4 newtons equals 1 pound. And, for example, because a human cannot give that much force as, for example, the horse. So it means that the human could only push it very slowly. However, the horse could do it 6 times faster than the human. So the human put around 80 newtons, while the horse put around 480 newtons. And we also know that 4 newtons equals 1 pound. So the human gave 20 pounds of force, while the horse gave around 120 pounds of force. 6 times again. And also the bicycle example, the one we kind of forget about. The one that, so if it has like a 100 pound barbell there, it'll be even harder. You have to overcome inertia, which makes it so you need a lot more force than if the bicycle did not have that much weight. And Newton's final law was, for every action there's an equal and opposite reaction. So we also expressed this in a bumper car example, where it bumps the bumper car, and the force that this guy put on this bumper car, he will also get that force because the bumper car will not bump him, but the same force will be passed on to the same bumper car that bumped that one. We also put this in the tipping boat example, as this guy, this stick figure here, put a lot of force on the boat, which causes it to tip. Now his last and final example we have is with the ping pong ball. Now the ping pong ball bounces when it drops, but it'll also come back up. So that's pretty much Newton's 3 laws. I hope this is pretty brief, but I hope you understand Newton's 3 laws of motion. Anyway, that's my time with you guys, and I'll see you in the next video.